Hello, everybody. I wanted today to go over the solution to one of the problems from a homework assignment on projectile motion. This problem is a challenging one. It's a challenge because they do not give you that much information. Now, many of the projectile problems we do by making an XY table, we can figure out which equations to use to solve step by step. However, in a situation like this, that method will not lead to a solution, because to answer this question, you will need to use a system of equations. So to see what's going on, let's go through it and take it piece by piece. And I will show you the logic of how we solve a problem like this. So remember, one of the most important things you need to do is to sketch a problem. So let's sketch the motion of the problem. So again, reading the problem, a quarterback throws the football to a receiver who is 31.5 meters down the field. If the football is thrown at an initial angle of 40 degrees, at what initial speed, that is, what is V naught, must the quarterback throw the ball? And again, there's not a lot of information given in the problem, but there is more than you would think. So again, the football, sorry for not drawing a football, but there you go, is going to follow a parabolic arc. If I put my origin at where the football is, then this distance x is known, and it's here for 31.5 meters. Well, the football is being thrown at an angle of 40 degrees. So there is velocity V naught. Now, whenever I see a vector at an angle, I like to break this down into an x and y component. So I can consider that my velocity V naught is really made up of an x and y velocity. Now, again, these velocities, the y velocity is really over here, but I'm already crowded up. Now, when the football lands, there are two places where you know the y velocity. At the very top of the motion, you know at the very top the y velocity will be equal to 0, and the x velocity will be equal to the original x velocity, will be unchanged. But you also know what happened at the end of the motion. As long as the football lands at the same height then it was thrown, and we can assume that the quarterback and the receiver are at approximately the same height, then the x velocity again here will not change. That is, the final x velocity will be v naught x, but the y velocity will simply be opposite whatever the initial y velocity is over there. So my final y velocity is equal to minus v naught y. Now, I do not know what v naught y is, or v naught x, or v naught at this point, so you may be thinking that you're stuck, but we're not. Let's just follow through and take it step by step and see where the math leads us. And this is a perfect example where you just have to trust yourself on the math. Now, first off, let's talk about v naught x and v naught y. I can write equations for those. I know the x involves cosine of the 40 degrees, and I know the y velocity will be equal to involving the sine of the 40. So the first thing I'm going to note is that v naught x must be equal to v naught, whatever it is, times the cosine of 40 degrees. Now that's going to just be a number. That's a decimal, but I know this number. I do not know v naught, but I know that v naught y is going to be equal to v naught times the sine of 40 degrees. And again, I do not know what v naught is, but I know it has to obey that expression. So now let's look at where the receiver catches the ball. Now, I know that vy is minus v naught y, so I can write the equation for vy. And again, I remind myself something else that I know is that the only acceleration in this problem is in the y direction. And I know that AY will be equal to minus G. That is, it will be equal to minus 9.81 meters per second squared. And I know that the x acceleration is equal to 0 meters per second squared because gravity only affects the y velocity. So I do know the accelerations. Well, I don't know the value of Vy or V naught y, but I know how they relate. So let's start with writing that equation. So in the y direction, and I always like to remind myself of which direction I'm working with, I know that the final velocity in the y is going to be equal to the initial velocity in the y direction minus g times t, because the acceleration is negative 9.81, so I just add that to my equation. Well, let's put in for Vy and V naught y. That means that minus V naught y is equal to V naught y minus g times t. Well, again, I know that the final velocity in y direction is simply opposite of what it went up with, so I can write that. Well, I'm going to move the V naught y over to the other side. Now, you might think that V naught y and the minus V naught y will combine to 0, but it won't, and this is the first reason why we have to be careful with our algebra here. If I add minus V naught y to both sides, I will get minus 2 V naught y is equal to minus g times t. Or I will get that the time t is equal to 2 V naught y over g, or that the time t would be equal to 2 times V naught sine of 40 degrees divided by g. Now, at this point, all I've done is use the motion equation in the y direction for the final velocity, and I get an expression for time. Now, I do not know what time is, and I do not know what V naught is. That means that I have an equation with two unknowns. So, math tells me that if I have two unknowns, I need two equations. Well, I've used the y direction, so let's use the x direction and come up with another equation. So in the x direction, I do know the distance the football will go. So I will start with the equation x equals x naught plus V naught in the x direction times time plus 1/2 the acceleration in the x direction times time squared. I'm going to have to move myself out of the way. There we go. I will put myself back now. So I'm going to cross out the things that are 0. Do that, I put my origin at the beginning. I'm going to start with no x displacement, and my acceleration in the x direction is 0, so that crosses out this complete term. Sorry about that. Now I zoop. So that crosses out that term. So my x equation becomes easy. X equals V naught in the x direction times time, or that the time is going to be equal to x divided by V naught x, or time is equal to x divided by V naught cosine 40 degrees. And again, I don't know what V naught is, I don't know what time is, but at this point you should breathe a sigh of relief because I have two equations for time. So I can set these two equations equal to each other and solve for what V naught is. Now, if you're trying to do this with all numbers, you're going to get probably lost pretty fast. It's possible. I could put in what G is. I could put in what the cosine 40 is and the sine of 40. But I'm just going to leave them be and just work with the equations as they are. So at this point, you go and get yourself your favorite beverage and relax because the hard part is done. It might not look at it, but we've figured things out. So let's just go through the steps again. At first, when I looked at this problem, I had no idea how I was going to approach it, so I start by making a sketch. I know that the initial velocity is going to be tangent to that parabolic path, and I know whenever I have a velocity at an angle, I should break it up into x and y components. There are two places in a projectile's motion where I know the y velocity. I know the y velocity at the top will be equal to 0, and I know the y velocity at the end will be equal to minus the initial y velocity. So based on that fact, I decided to start in the y direction and write the equation for the final y velocity. That gave us an expression here for time in terms of the original velocity, which is what I'm looking for, and time, which I do not know. Because I didn't know time and I have two unknowns, I realized I needed a second equation. Since I already worked with y, I worked with x. I write the x equation out for the motion of the ball, and I realized that this simplified to something quite easy, that time was equal to x divided by v naught x, or the original velocity in the x direction, which was the original velocity times cosine 40. So that, I just followed the breadcrumbs of the math as we went through. So now let's move this up. Oops. And let's find out what this x value actually is. So again, I'm going to just recopy these equations. I know that from the y direction, I got that time was equal to 2 v naught sine 40 degrees divided by g, which is just 9.81. And I know in the x direction, I got that time was equal to the distance x divided by v naught times cosine of 40 degrees. And I know that x was equal to 31.5 meters. And for good measure, I'll remind ourselves that g is equal to 9.81 meters per second squared. All right, well, I'm going to set these two equations equal to each other. So I get 2 v naught sine 40 degrees over g is equal to x over v naught cosine 40 degrees. I want to get my v naught terms together. So what I'm going to do is I'm going to cross multiply. I will multiply this term over to the other side and the g over there. So when I do that, I end up with 2. The v naughts are going to square, so that's v naught squared. The sine and the 40 will multiply each other. Sine 40 degrees times cosine 40 degrees. Now that may look scary, but these are just two decimals being multiplied. And that's going to be equal to x times g. Now, I point out that g is in meters per second squared and x is in meters, so x times g is going to be equal to meters squared over seconds squared. So that is exactly what it should be, because v squared is going to be meters squared per second squared. So this gives me an indication that I've set up the math correctly. So now let's solve for v naught squared. So I'm going to need to divide the 2, the sine, and the cosine over to the other side. I will get x times g divided by 2 times sine 40 degrees times cosine 40 degrees. Before I reach for the calculator, let's put checks away. No, we know the x value. We know the acceleration due to gravity. Sines and cosines are just numbers. So as long as I'm in degree mode, we should be good to go. So let's solve this. So v naught squared is going to be equal to, that's 31.5 meters times 9.81 meters per second squared divided by 2. Well, I'm going to use my calculator and replace those trig values with decimals. Sine of 40 works out to be 0.6428. I'm using 4 sig figs, so I'll round at the end, just be careful. Cosine 40 works out to be 0.7660. All right, well, let's do the math. That's 31.5 times 9.81. Divide by 2. Divide by 0.6428. Divide by 0.766. I get, this is equal to 313.8. that means that V naught will be equal to the square root of 313.8, or V naught will be equal to 17.7 meters per second, and we are done. So the hard part of a problem like this is to make that sketch and not worry that you don't know a lot of things. Just see where the math leads. But the previous problem in the homework assignment is much like this, except for the final velocity is at the top of the motion, which would be a final y velocity of 0. And then you have to remember then at that point of the path, you'd only use half the x. So your x value is not what is actually in that problem. But I hope this example helped, and I'll see you in class.